Hi friends, so let us continue with our reflection and refraction problems. So question is, show three types of ray diagrams, important ones for convex and concave lenses. So we have shown it here. See, this is a convex lens. Okay, now as we have described before, it has two focal point on each side and two center of curvature on both of the sides. Okay, and if you shoot a ray which is parallel to the principal axis, it will be bent by the lens such that it passes through the focal point on the other side. Okay, so this is a ray which is parallel, it gets bent by the lens, and that ray will go through the focal point on the other side. This is one type of ray. In case of a concave lens, as you know, it is a not a converging but diverging lens. So when you shoot a ray which is parallel to the principal axis, it will diverge it. Okay, it will bend it and diverge it away, but the divergence will happen such that if you backtrace, it will appear to be coming out of the focal point. Okay, so parallel gets diverged, but it appears to diverge from the focal point. Second type of ray is, if you shoot a ray through the focal point on one side, the lens will bend it such a way, the convex lens will bend it such a way that it becomes parallel to the principal axis. See this ray, you have shot it through the focal point. Okay, the lens will bend it such a way that it is now parallel to the principal axis. Okay, for concave lens also, if you shoot a ray in the direction as though it is going through the focus, see here, this ray is shot such that if you extend it, it goes through the focus. So this ray will get bent such that it becomes parallel to the principal axis. Okay. Third type of ray is simple. If you shoot it through the optical center, it will not change its direction and it will keep on going. Same for concave lens also. If you shoot a ray through the optical center, it will not change the direction, it will keep on going in the same direction. So these three rays, type of rays, both for convex and concave lens, are important to understand so that we can study the image formation when object is kept at various places for both convex lens and concave lens. Okay. Next question, show image formation for convex lens, object at infinity. Okay, see this AB object is at infinity. Because it is at infinity, it is very far, only the parallel rays from that object will reach the lens. Okay, so as we know, as we have studied here, the parallel line will be bent by the convex lens such that it goes to the focus. So if you look at this case, the ray is parallel and it gets bent. The ray from A is parallel, it gets bent and it goes through the focus. The ray from B is also parallel, it gets bent and it goes to the focus. So the image is formed at the focus. Okay, so when object pose is at infinity, for a convex lens, image pose is at focus and the size of image is highly diminished. Okay, because both point A and point B are getting focused to the same point, and it is real and inverted. Okay, so next question, show the image formation for convex lens when the object is beyond C. Okay, so here's the C, center of curvature. When the object is beyond C, what happens? So again, shoot a ray which is parallel to the principal axis. When such a ray is shot, as you know, it will be bent such that it goes through the focus. Okay, and shoot a ray through the optical center, and when you do that, as you know, it will keep on going without changing direction. Now these two rays emerging from point A of the object is AB. A has the up arrow so that it is standing straight. A is the top point. So two rays emanating from point A will intersect here, right? At which point the image will be formed, A dash, and B dash will be formed here. So if you position the object beyond C, right, image position will be between F and C on the other side. Okay, the object is on this side, the image is on this side. Okay, and the image is between F and C on the other side. And you can see the size of the image. See, AB is this object, but you can see A dash, B dash, its image is smaller, so the size is diminished. And the type is real inverted. Next question, show the image formation for convex lens when object is at C. Okay, so here is what is happening is AB is positioned exactly at C. So if you shoot a ray parallel to the optical axis, it will go through F. If you shoot another ray through the optic center, it will go in the same direction without any change in direction. These two guys will intersect here, and you can see the image is formed. The point A's image is A dash. It is formed exactly at C on the other side. Okay, and you can see the size is also same, but this is inverted. Okay, so if you place object at C, the position will also be at C of the image will also be at C, but on the other side. And as you can see, the sizes are equal. Okay, and it is a real image, but it is inverted. Okay, next question, show image formation for the convex lens when the object is between C and F. Okay, when it is between C and F, again do the same technique, shoot a ray parallel to the principal axis. It will be bent such that it goes through F. Shoot a ray through optic center, it will go straight as is without changing its direction. These two rays emanating from A will intersect at A dash, and the image of B dash is on the principal axis. So A dash B dash is the image. Now as you can see, it is inverted and its size is bigger than the object AB. Okay, and it is sort of image is formed beyond C on the other side. Okay, so the position of object, if you keep it between C and F for a convex lens, the position of image form will be beyond C on the other side. Okay, because image is on the other side, and the size of image, it is large, enlarged, bigger than the size of object. Type of image, it is real and it is inverted. Okay, so next question, show the formation for convex lens when object is kept at F exactly. Okay, when object is kept at F, again you do the same technique. You shoot a ray parallel to the principal axis, it goes in this direction through F. You shoot a ray through the optic center, it goes the same direction without changing direction. And these two lines never intersect because they are parallel. Okay, so they intersect at infinity, right? Which means image is formed at infinity. So when you position the object at F for a convex lens, the position of image is at infinity. Size of image is enlarged because A will be formed somewhere here in the infinity and it will be very big. And the image is real and inverted. Okay. So next case, show the image formation for convex lens when object is between F and optical center O. Okay, now see what happens. You do the same technique. This is object AB. From A you shoot a ray parallel to the principal axis, it gets bent and goes through F. You shoot another ray through the optical center O and it goes in the same straight line without changing direction. Now you can see that these two lines, these two rays are diverging. Means they are not intersecting, they are diverging like that. Okay, when they are diverging like that, if you backtrace them, they'll intersect behind the object. Okay, and you can see they intersect at a point which is behind the object, and A dash B dash is the image formed. Okay, and you can see that because of this divergence, it is a virtual image. Okay, it cannot be captured because of the divergence. It cannot be captured on a screen, it can only be seen. Okay, so when you position the object between F and optical center, the position of image is beyond F on the same side as the object. Size of the image is enlarged. You can see the image is bigger than the object, and type of image is, it is erect but it is virtual. Okay, what about concave lens? For concave lens there are only two interesting cases. One case is when the object is at infinity. Again, AB is at infinity, so from very far only parallel rays will reach parallel rays. There's a mistake here, I'll correct it immediately. So basically this is not a converging lens, this is a diverging lens. So let me correct that immediately. So these rays must not be like this. These rays get diverged because see, this is not a convex lens, this is a concave lens. So I'm just correcting it right away. Okay, so this is a concave lens, so the rays will get diverged and the image is formed at F but on the same side as the object. Okay, so this will get diverged like this. Okay, But if you backtrace it, you can see I'm backtracing it, it hits the F. Okay, similarly this also will get diverged like this, right? But when you backtrace it, it will appear as though it is coming from F. Okay, so this rays get diverged like this. Okay, AB, this ray gets diverged like this, the ray from B gets diverged like this, but they appear to be coming from focus F. So in case of a concave lens, okay, it's a diverging lens, and if you place an object at infinity, the image will be generated on the same side at the focal point. Okay, that sorry for the error, I had drawn it as converging. This is a concave lens, it diverges, so this is correct. This ray gets diverged like this, this parallel ray gets diverged like this. When you backtrace them, they appear to be diverging from F, so that's where the virtual image is formed. Okay, next case, what if it is not at infinity? Okay, what if it is at somewhere beyond C but it's not infinity? At that case, you do the same technique. You draw a line which is parallel to the principal axis. It gets diverged. It gets diverged in such a way that it appears, when you backtrace it, it appears to be coming from F. Okay, and one more ray you pass it through the optical center. Because you are passing through the optical center, it doesn't get diverged. It continues in the same direction. Okay, now these two rays, the one which diverges and one which goes along the same direction, you can see that when you backtrace this, they both intersect at this point A dash. So the image is formed here, the small image A dash B dash, it is formed here. Okay, so the image is smaller. Okay, and because of this divergent rays, it is a virtual image, and it is, the size is diminished, and it is formed between optical center and F. So for concave lens, when the object is not at infinity, the image is always formed between focal point and the optical center, and it is diminished. Thank you, friends.